Welcome to the C++ Sports Report. Today we have a new interesting topic with the new season coming up in data structures, and we have a preview of the new season of programming. You're watching the C++ Sports Report with your host, Joshua C. Post. Today the data structure season is coming up soon, so we're going to drop you with a preseason into the preseason schedule, what's going on, the league. We got the intro to talking data structure preview coming up. Look at intro. What is data structure? And with the new season coming on, it doesn't make sense not to know what data structure is. We're going to be tuning into the seasons. So let me give you a little brief definition of what data structure is. Data structure is a collection of data elements whose organization is characterized by assets and operations that are used to store and retrieve the individual data elements. That being said, we can now jump into the intro to some data structures topics. We're going to talk about robustness, sorted clear box testing, data encapsulation, overloading. The preview of what the data structure season is going to look like when it first starts. We got clear box testing, robustness, sorted list, data encapsulation, and last but not least, coming up is overloading for the first 5 data structures. Let's get the regular season started. What clear box testing? It's our first data structure component. So, what is it? Clear box testing is when you're testing a program or function based on testing every path or covering all parts of the code. We do this because it's sort of an exhaustive form, which means if we cover everything, then we know that every part of the code does this, does that, does what we need, and doesn't do what we need. It's just a form of testing that some choose and some choose not to do. Let's get the first play one. We're going to show you how it runs. Over here, we got a little code, just a little pseudo code kind of thing. We have 2 paths in this code. We have a path for if f is s equals 3, and we have a path for any other input or any other value of x. So in this situation, we will test this value coming out, so we can see the first path is s is 3. Test that value, and it'll do something cool. Then we'll rerun the program and test this value, make x 4 or something of the sort, something that's not equal to 3, and we'll have it be able to do the other path, just do something lame. Or obviously in this case you want to do something cool, so we try to get that now. Second topic, robustness. Robustness is just the ability of a program to recover in its own environment if error should occur. We do this. Why? Because you don't want to get your user using the program and they say they don't enter the right PIN number in for ATM machine, and instead of asking them to re-enter the PIN code or tell them that the error is wrong, re-enter your card, you have them look at a screen that says error, blah blah, oh crash. You don't want that to happen. So for example, we're going to do one of the second play, which is going to have explicit exceptions. Now, what I mean by explicit exceptions is that you will specifically describe what an exception would do. You have other types of ways like try and catch and throw and all those kind of things. You have, what to do, but in this case, we're just going to do with explicit exception. We're going to have while y equals true. We're going to have this set up, and while y is true, we have that so it can loops. So if x is not equal to 3, we're going to see out that that's not a valid input. Obviously in this code we want the input to be 3. So once we do enter 3, if we not enter 3, it see out this error printed out to the screen, not a valid input. And then if y is true, would say in the menu program, as long as the user does not use an exit number, like say exit or cancel or something like that, then it'll repeat the program until they give them a proper error. Now, in this case, if you do put the right value in, which is 3, it'll do something cool. It's a simple pseudocode. You want this to happen. This is where the program is able to compile and continue on its own environment. Sorted list. Sorted list is just a list with elements sorted by a particular key. A key is a particular component of a code of the list that lets you know what is sorted. So we do this because it makes it easier to display data, search for data, etc., inside of the code. Now we're going to show you what a sorted list looks like, so you get an idea better about the sorted list. Sorted lists have no key to sort them. So we have a group of names. We can assume that they're just have nothing in common, and it's, just Kyoto, Arizona, Montana, Texas, Kansas, Jerry. You can see the states might have something in common, but then you have a Japanese city, you have a shortened state name, and you have a known terminus. So you can't say that this is sorted, but you can only assume that it's unsorted list. Then you have sorted lists, and we're going to run this third play, which is sorted. The key is going to be alphabetical order. Here we have Arizona, Jerry, Kansas, Kyoto, Montana, Texas. Now you can't say that it's sorted unless it explicitly says that it's sorted. And since the keys this explicitly says it's sorted alphabetically, we have Arizona first, Jerry first, Kansas first, Kyoto first, Montana, and Texas first. The thing about this is, once we get it sorted, there's a lot more we can do with it, and it makes it easier to display data. Data encapsulation. What is data encapsulation? Data encapsulation is the separation of data from application that uses the data at a logical level. Now we do this so that you can't have a user come in and change things in your code that will cause the code to crash or not perform properly. So what we're going to have an example here is to run the fourth play, which is private and public. User only can direct to change what is public, and we have an user be able to change the input. The private section has the array formats items. So in this case, we have a program to say, let's add a number of grades. We have a list of grades, something like that. We have the user to input what grade that he wants to put. He puts the input 54. Okay. He doesn't change the array, but he wants that value inside the array. So what we do is we design a program that lets someone be able to pick this value, have a function set up that adds that value into this function without the user actually changing this function. That way the program designer can still control what happens to the array, and nothing, an error or compile function, something wrong won't occur. So in this case, we'll have input as like someone makes it 54. We'll have a function say add grade. Say yes, want to add a grade. What's input grade? 54 would be for the input. We'll have input, use something like a push function or add item function, and they'll just put whatever he put in for input into the array with max items. And then we have our last topic of today, overloading. What is overloading? Overloading is giving the same name to more than one function or operator symbol for more than one operation. Now what does that mean? It means that we get something like this. Let's say a function called drive. Our code is fast. We don't want to keep really declaring different functions to do different things when they're all related to driving. So what we do is just simply we overload drive so it can do more than one thing. Here's an example. Simple overload. We're running the last page and I'm going to teach y'all today. What we're going to do is we have 3 print functions. One is for int, one is for double, and one is for char. With this, we're able to define the print function 3 different times with 3 different data types. The first one being int, the second double, and the final one being char. What we do is go to the second part. In the main, we have 3 different print functions. You see, we have the call to these print functions. Now, what's going to happen is the overloaded function is going to decide which one to use based on its parameters. Since considering that the first one was an int, and we give it an int, it's going to say, hey, this is an int. This char function, this double function does not work for this. So, since I have an int function, I'm going to use this int. And the program prints out, here is int 10, as we saw earlier in our function. Now we have, let's go to the double. This double, we wanted to print out a float. There we go. It says, hey, this is the double. Let's get this correct. And it prints that out. And basically, that's what it happens into this overload. It's just basically a function that we can use more than one way. I mean, why would in the VS Code this is very useful and it is very appropriate. Thank you for watching another episode of the C++ Sports Report. It's your host Joshua C. Fogan, and for the rest of my staff and crew, catch you next time.